it has been observed that any object which is dropped from a height, it falls towards the earth, right? So if we drop an object from a height, it drop, or you can say it falls towards the earth, right? So Newton generalized this idea and said that not only the earth, but every object in the universe attracts each other. Okay? And this force of attraction between the two objects is called the force of attraction, or you can say force of gravitation, or simply gravitational force. Right? So now in this chapter, we will learn about what is gravitation, what are the universal law of gravitation, right? And how we can solve the numericals using it. Okay? So write down gravitation. Okay? So how we will define gravitation? The definition is that it is defined, everybody please write down, it is defined as the force of attraction between any two bodies, in the universe, right? So in the universe, the force of attraction experienced between the two bodies, by the two bodies, is a force of attraction, right? That is gravitation, right? Earth attracts, or it pulls all objects. Yes or no? It pulls all objects lying on or near its surface towards its center, right? So Earth is behaving like a magnet, right? And this force of attraction of Earth is because of its mass, huge mass, right? So because of this, Earth is attracting, or it is pulling all the objects which is lying on the Earth, or maybe it is near the surface of the Earth towards its center. Okay. So the force with which the Earth pulls the object towards its center is called the gravitational force of the Earth, or simply gravity of the Earth. Okay, so write down. So how we will define this? The force with which the Earth pulls the object towards its center is called the gravitational force of the Earth, or simply gravity of the Earth. Okay, so every two objects is actually attracting each other in this universe, right? If we talk about Earth and the object which is lying on the surface or near the surface of the Earth, right? So since Earth is a big body, right, having a huge mass, so its gravitational force is too much, right? Okay, in comparison to the other objects, right? And there's a reason it is attracting, right, each and everything, right, with a force, right? Now, what is the universal law of gravitation? Put the heading. Universal law of gravitation. Universal law of gravitation. Put the heading. Now, this was given by the scientist Isaac Newton. According to this law, the attractive forces between any two bodies in the universe is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Getting it? Right? So what this law says, that given by the Newton, that the attractive force between any two bodies in the universe is directly proportional to the product of their masses, m1 into m2, right? And inversely proportional to the square of the distance between them. Suppose r is the square between the two objects m1 and m2, then it is inversely proportional to the square of the distance between them. And the direction of the force is along the line of the joining the centers of the two objects, right? Okay. So let's write down. So this is the universal law of gravitation, right? That means the attractive force between the two bodies is always directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Now consider two bodies A and B, right? Suppose there are two bodies A and B. Suppose these are the two bodies. Okay. Body A and body B, right? There's the center of the two objects, right? M1 is the mass of object A, body A, and M2 is the mass of body B, right? Okay. D is the distance, suppose, right? So the distance, this is the distance between the centers of the two bodies, okay? And if we draw a line joining the centers, right? This line will tell you the force of attraction, right? Among the two bodies exerted to each other, right? Okay, so direction of the force between these two bodies is directed along the line of joining of the centers. As you can see this line, right? Now, if this is the case, these are the two bodies, then what will be the force, right? So according to the law, the force will be directly proportional to the product of the masses, means M1 into M2, right? Okay, equation number 1, right? And it is inversely proportional to the square of the distance between them, means F is proportional to 1 upon, if it is D, the distance between the two objects, then this is D square. Okay, D is the distance between the centers of the two objects, right? So according to this universal law of gravitation, this F is directly proportional to the product of the masses of the two objects and inversely proportional to the square of the distance between them. Now, combining 1 and 2, what we get? We can write that F is proportional to M1 into M2 upon D square, right? Okay. Now, this is a proportion which we are writing here. And whenever we remove the sign of proportionality, right? Whenever we remove this sign, we always put a constant, right? So whenever we convert this proportional sign into equal to, we always multiply with a constant, right? So F is equals to, so since we have converted this proportional sign into equal to, we need to multiply with the constant. And this time the constant is G, right? What is this constant here? This constant is G. G M1 M2 upon D square. Is it clear? Right? Okay. So F is G into M1 M2 upon D square. I hope everybody understood like how we have got this formula, right? So according to the law, force is directly proportional to the product of the masses, inversely proportional to the square of the distance, right? So by this we get F directly proportional to M1 M2 upon D square, and when we remove the sign of proportionality, we'll put a constant, we multiply with the constant, that is G here, right? Okay. Now, here G is, the value of G is, because it is a constant, there is a value, fixed value, and the value is 6.67 into 10 to the power minus 11 Newton meter square kg square. And this G is called universal, this G is called universal gravitational constant, right? So what is the name of G? G is universal gravitational constant, right? So this G is a universal constant, means the value of G will remain same in the whole universe, right? It will remain same, 6.67 into 10 to the power minus 11 Newton meter square upon kg square. So this is constant because its value does not depend upon the medium between the two bodies and the masses of the bodies or the distance between them, right? It does not depend on, right? Okay. So now, if we assume, suppose the masses of the two bodies, m1 equal to m2 is equal to 1 kg, both are 1 kg each, right? And the distance between them is suppose 1 meter, right? Then if we put everything in the formula, this will be equal to, so this will be 1 into 1, and d square, that will be 1 square is also 1, right? So what you will get? You will get that F is equal to G. Getting that? Okay. In this case, what do we get? F is equal to G. Right? So how we define this universal gravitation constant? We define it as hence G, that is universal gravitation constant. So there's a definition which I'm telling to you now. Definition of G, capital G. Universal gravitational constant G is defined as the gravitational force between two bodies of unit masses and they are separated by a unit distance from each other placed anywhere in space. So we can place these masses anywhere because G does not depend upon the medium, right? Okay, it does not depend upon the masses, right? So what is this G? E will be equal to F. When this is equal to F? When bodies are of unit masses, 1 kg each, and they are separated by unit distance, that is 1 meter, right? Then in that case, G will be equal to F, right? So in this way, we have defined the gravitational constant, that it is that force when two bodies of unit masses are separated by the unit distance, and it can be placed anywhere in the space. I hope everybody getting this. The SI unit of G is SI unit. The standard unit of G is Newton meter square kg square. Okay. And the value of G, that is 6.67 10 to the power minus 11 Newton meter square per kg square, was found by Henry Cavendish in 1730s, right? By using a sensitive balance. Okay. So this is the unit of G, Newton meter square per kg square. Right? So I hope you're getting like what is the universal law of gravitation, what is universal gravitational constant, and how we can define it. Everybody getting this? Please tell me. Importance of universal law of gravitation. So this gravitational law means universal law of gravitation successfully explains so many phenomena on Earth, right? For example, it explains, first write down, the universal law of gravitation successfully explain the phenomena is, first is the force that binds us to the earth, right? So we are bind to earth, right? Yes or no? There is some force which is binding us on earth, right? Okay. So this phenomena is explained by this law, gravitational law of gravitation, universal law of gravitation, right? Okay. So it defines this phenomena that there is some force which is binding us towards the earth. Then the motion of the moon around the earth, right? So the reason behind that moon is revolving around the earth is because of this gravitational force, right? The motion of planets, right? So these are all important phenomena. Motion of the planets around the sun, right? So there are so many planets which are revolving around the sun, including Earth, right? The occurrence of tides, right? Tides are occurring because of this. Occurrence of tides is due to the gravitational force of attraction of the moon. Okay. So write down. It is due to the gravitational force of attraction of moon. The flow of water is flowing in the rivers is also due to the gravitational force of Earth on the water. Gravitational force of the Earth on water. So these are important phenomena which are occurred or which are occurring on Earth or in the space, right? And these phenomena are successfully explained by the universal law of gravitation. Now let's see what is the motion of the moon around Earth and what is centripetal force. So, as we know, the force that keeps a body moving along a circular path, right? So, whenever a body is moving in a circular path, there is a force that keeps a body moving into that circular path is acting towards the center, and that is called the centripetal force or center seeking force, right? So the motion of the moon around the earth is due to the centripetal force, right? It is force of attraction, but along with that, there is a centripetal force which generally applies whenever a body is moving in a circular path. And the centripetal force is provided by the gravitational force of attraction of the earth. And if there were no such force, then the moon would pursue a uniform straight line motion. Are you getting that? So all the bodies which are moving circular, right, or revolving, right, around a particular object, right? So there is a centripetal force towards the center, right, which is acting, and this centripetal force is provided by the gravitational force, right? Similarly, is the reason like why other planets are revolving around the sun, right? So there is a centripetal force which is because of the gravitational force of the moon, and so on the on other planets, right? Similarly on the moon by the earth, right? So what is this centripetal force? So write down the force that keeps a body moving along the circular path is acting towards the center is called centripetal or center seeking. Centripetal means center seeking towards center, centripetal force. Okay, so are you getting it? What is centripetal force, right? So the motion of the moon around the sun is due to the centripetal force. Due to the centripetal force provided by the gravitational force of attraction of the earth. Is that clear? Please don't know. If you want to understand this little more, more clear way, just think about that piece of the stone which may be tied, to one end of a string, right? So you have done sometimes maybe while playing. And if you hold this, the other end of the string in the hand and just whirl it at a constant speed, right? So the stone starts moving in a circular path with some certain speed, right? But its direction of motion changes continuously, right? Yes or no? Because there's a circular motion. And the change in direction of the motion involves change in the velocity, or you can say the acceleration also, right? Now the external force that causes this acceleration and keeps the stone moving uniformly along the circular path is acting towards the center of the circular path, and this is the centripetal force, right? That is center seeking force. So if at any instant, if you release this string, so what will happen? The stone will fly suddenly, right? Along a tangent. Have you done this ever while playing, right? So a stone which is tied at, at the one end, and the other end of the string you are holding, and you are just, whirl it in a circular motion, right? And suddenly you release this string. The stone will fly along the tangent to the circular path at that instant, right? And why this is? Because of the moment of the string is released, the centripetal force is no longer provided, right? And stone is free to fly off along the tangent line, right? So from these activity you can say that the motion of moon around the earth is due to the centripetal force, and which is provided by the force of attraction of the earth on the moon, because there is no string which are in between moon and earth. So from where this force is coming? That is from the force of attraction of the earth. Is that clear? Are you getting it? Always remember that the force of gravitation is always the force of attraction. It can never be repulsive. Okay? So gravitational force can never be repulsive, that it repels some object, right? It is always attract the object, right? It is a force of attraction. It is not a force of repulsion. It can never be a repulsive force. Is that clear? Yes or no? Now, let's see one or two numericals based on F, that is equal to G m1 m2 upon d square, right? Question number 1, write down. Now look at this question. Find the gravitational force between Earth and object of 2 kg mass placed on its surface, right? Mass of the Earth is given 6 into 10 to the power 24 kg, and radius of Earth is 6.4 10 to the power 6 meters, right? So what are two bodies here, two objects here, where we have to find the gravitational force between them? One is Earth and other is the object which is placed on Earth, placed on its surface, right? Okay, Earth is having its mass, which is given here, 6 into 10 power 24 kg. Object is also having some mass, but that is very small, 2 kg, right? Okay, and the radius of Earth is 6.4 into 10 to the power 6, right? Okay, so first we will write down what is given. So mass of Earth, ME, is the mass of Earth, 6 into 10 to the power 24 kg. Mass of an object, MO, suppose, mass of object, it is 2 kg, right? So these are the two masses or two objects. Now distance between the Earth and object, is it equal to radius of Earth or something else? Can you tell me? What will be the distance between the Earth and an object? Because in our formula, we have a distance between the two objects, between the center of the two objects, right? So what we will take? Can you tell me? Distance between Earth and the object. This is always equal to the radius of the Earth, right? That is R, which is 6.4 into 10 to the power 6 meters, right? So why we are taking distance between the Earth and the object equal to the radius of the Earth? Why? Because suppose this is the Earth, right? Earth is very big, right? And suppose this is the radius, okay? And this object is placed here, right? Now from here to here, this, that distance is very, very negligible in comparison to R, right? So we just take it equal to R. So any object which is near to the surface of the Earth or on the surface of the Earth, the distance between that object and Earth, we take it equal to radius of the Earth. Are you getting that? Right? And that's the reason the D is R here, right? The distance between the two objects is taken as the radius of the Earth. Okay, everybody getting it? Now we have to find gravitational force. Gravitational force F. Okay, right? Now, by the universal law of gravitation, we know that F is equal to G, M1, M2, okay, upon R square, right? So here our D is R, okay? Now, G is the universal constant and its value is 6.67 into 10 to the power minus 11, right? Then we will put the values of M1 and M2. M1, that is mass of Earth, 6 into 10 to the power 24 kgs, into M2, which is 2 kg, right? So we will write down everything here in the formula. R is the radius of the Earth, which is 6.4 into 10 to the power 6, then it's square, right? Now we will solve this to find out the, okay? So after calculating this, right, we get 19.5 Newton, right? So what is the force of attraction between that object and Earth? It will be attracted with a force of 19.5 Newton. Is that clear? Everybody getting this?